All right, in these, on the screen you can see two terms separated by a plus sign equal to 0, and our job is to solve that by factoring. Let's try factoring two terms that are much easier to work with, something that you might have seen in, say, a beginning algebra class. 10a cubed b to the 5th plus 15a to the 5th b squared. The plus sign there separates one term from the other. And let's look at the greatest common factor. It could be a number or a letter, or in this case it'll be both. Let's look at the numbers first. The greatest common factor of 10 and 15 is 5. Then let's look at the a's. You've got an a cubed in the first term and an a to the 5th in the second term. Which is smaller, 3 or 5? 3 is smaller, so a cubed is the most you can factor out of both terms. Then let's look at the b's. Which is smaller, 5 or 2? 2 is smaller, so that's the most. B squared is the most you can factor out of both terms. And right next to it we'll draw an empty set of parentheses. What you're doing is like the distributive property in reverse. You know how you distribute the term, you distribute the factor in front times everything inside the parentheses. So let's think of that in reverse. And inside this first blank space, I'm going to put whatever I need to multiply the GCF by to get the first term. So in that first blank space in the parentheses, what do I need? Well, I need a 2 and a b cubed. Why? Because if I multiply 2b cubed times the GCF, I get the first term. Now, copy down the plus sign, and let's look at the second blank space inside the parentheses, and in there we're going to need a 3 and an a squared, and that's it. Again, if you use the distributive property to multiply the GCF times that and that, you get the original problem. So we're done, we've got the right answer. So that's the technique we're going to use to solve this more complicated problem. Okay, ready? Let's take a look at it. In the first term and the second term, x and 7, there's no GCF for x and 7, but I do see this quantity, x squared minus 2x in parentheses, that's common to both terms. And I need to factor that out, but I need to raise it to some power. What power do I use? Well, again, follow that same technique I used a minute ago. Which is smaller, 1/3 or 4/3? 1/3 is smaller. So that's the most I can factor out from both terms. And that, ladies and gentlemen, is the GCF. Next to it, I'll draw an empty set of parentheses, or some brackets in this case, because it's going to be a little more complicated. And in this first blank space inside the parentheses, inside the brackets, I'm going to put whatever I need to multiply the GCF by to get the first term in the original problem. I'm going to need an x, and that's it. Because if I multiply x times the GCF, look, I get the first term in my original problem, so I'm done. Then I copy down the plus sign. And what goes in the next blank space in the parentheses? Well, I'm going to need a 7, and I'm going to need the x squared minus 2x raised to some power. And the question is, what power is that? Well, recall when you multiply terms and their bases are the same, you add the exponents. So what number, where the purple question mark is, would I add to the 1/3 to get 4/3? Well, duh, I would add 3/3, or 1. So right here, I'll leave it just like it is. There's no exponent showing, but of course it's understood to be a 1. So now if I use the distributive property and multiply this times the GCF, I get the second term. And if I multiply this times the GCF, I get the first term. So I have successfully factored my expression correctly. And of course it's equal to 0, and now our job is to solve for x. Inside the brackets, I can simplify. I can distribute the 7. And inside the parentheses, I can combine like terms. So 7x squared minus 13x. Okay, to solve this, you want to make sure it's factored completely. And I see an x that can be factored out of that second set of parentheses. And what's left is 7x minus 13. There, so if I multiply those three things together, I still have my original problem. You could actually factor an x to the 1/3 out of here, but I'm gonna let that go for now. So I'm gonna say now we've got our expression factored completely, and you can set each factor equal to 0. So with x equals 0, there's our first answer. If x squared minus 2x to the 1/3 equals 0, that means x squared minus 2x equals 0. And now you can factor that and set each of those factors equal to 0. So x equals 0, but we've already got that as an answer. So here's our second 0, our second root. And finally, let's solve this, and we get a fraction for an answer. That's about 2, or a little less than 2. It's like 1.9 or something. But that's just an approximation. It's rounded off. The exact answer is 13/7. So there, ladies and gentlemen, are our three solutions. So that's how you solve this, by factoring and setting each factor equal to 0. Now you want to see something really, really cool? These three roots that we found are actually the x-intercepts. So if I scroll back up to the top and take my original function and display the graph of it, it should cross the x-axis at these three places. You want to try it? Open up the graphing calculator, and it looks like before I started recording the video, I typed in the equation. Follow my cursor. There's the first x-intercept, the first 0, x equals 0. Here's the second one, x equals 2. And here's the third one, x equals 13/7, or about 1.9. So I feel good, since the graph cuts across the x-axis exactly where I solved, exactly where I found my zeros to be at. I feel good. I feel pretty comfortable that my three answers are correct. Okay? Hope that helped. Thanks for watching.